Lumen point. Let's begin the breakdown.
How big can a person really get? It's a question that sounds super simple, right? But the answer? Well, it's going to take us from the code inside our own bodies all the way out to the farthest reaches of the universe.
Okay, let's start with a number. 10 centimeters. That's about 4 inches. So what's the big deal with this number? Well, get this. It's how much taller the average person is today compared to just 150 years ago.
So, what gives? Are we evolving into giants? Not exactly. It's not like our DNA has fundamentally changed. What's really happening is that, with better food and better healthcare, we're finally reaching the full potential that was already written into our genes all along.
Okay, so this huge growth spurt, it brings up a really fascinating question, doesn't it? If we keep getting bigger, is there a limit? Like, what's the absolute physical maximum size for a human being?
I mean, we've all heard of the record holders, right? The tallest person alive today, Sultan Kosin, he's a staggering 8'3". And then there's the tallest person ever recorded, Robert Wadlow, who is an unbelievable 8'11". Now, these incredible heights are usually caused by medical conditions, stuff that sends their growth hormones into complete overdrive.
But seeing these examples really pushes us to ask a core scientific question. Let's put those medical conditions aside for a second. Biologically, what's the limit? How big can a human body get before it just stops working?
Well, it turns out the answer isn't just in our biology. It's actually baked into a fundamental rule of geometry. It's called the square-cube law.
Okay, so what on earth is the square-cube law? It's this super important idea that basically controls how big things can get. The gist is this. As any object gets bigger, its volume, and that means its weight, grows way, way faster than its surface area, which is where its strength comes from.
To make this crystal clear, just picture a simple cube, right? Now imagine you make that cube 10 times taller. Its surface area, which you can think of as its structural strength, gets 100 times bigger. But its volume, its mass, its weight, that balloons by a factor of 1,000. You see the problem here, right? The mass just doesn't add up.
So, let's apply that to a person. If you suddenly became 10 times taller but kept the same proportions, yeah, your strength would go up by 100 times, but your weight would shoot up by 1,000 times. Your own skeleton wouldn't be able to handle it. You would literally be crushed under your own weight.
And it's not just about your bones snapping. Our entire biology is scaled perfectly for our current size. To support a giant, our bones would have to be ridiculously, monstrously thick. Our heart, no way it would be strong enough to pump blood all the way up to a giant head. Basically, here on Earth, gravity becomes an enemy you just can't beat.
Okay, so physically, it sounds like we're pretty limited. Bummer. But what if we've been asking the question all wrong? Let's just pause for a second and totally redefine what size even means.
No, seriously, think about it. What does size really mean? Are you just the stuff packed inside your skin, or is there more to you? Where do you, begin and end? Let's try a different way to measure ourselves. What if we measure our size not by inches and feet, but by the impact we have on the world around us, the space that we can fill with our very presence? And that brings us to this really cool idea of our sensory bubble. So, how big are you when we measure you by how far your sound travels, how far you can be seen, or even how far you can be smelled? And when you look at it this way, the results are kind of wild. Your loudest shout, it can be heard from about 5 kilometers away. Not bad. On a really clear day, someone could actually spot you with their naked eye from up to 15 kilometers away. Pretty far. But look at that last bar. It just completely blows the others out of the water. This is just, wow. A grizzly bear, with its absolutely incredible sense of smell, can pick up your scent from nearly 30 kilometers away. That's almost 18 miles. So think about what that means. If you measure your size by the bubble in which other animals can detect you, your largest dimension here on Earth isn't physical at all. It's your smell. But believe it or not, we can go even bigger than that, way bigger. If we leave Earth behind and look out into space, we find a dimension to our size that is truly, truly mind-bending. And it all starts with a simple fact. You glow.
Yeah, you heard me. You emit light. It's a scientific fact. But just let that sink in for a moment. You are a source of light. Right now, as you're sitting there, your body is radiating energy. Most of it is infrared, it's heat, but it is a form of light.
And this light is made of photons. They're the tiniest possible packets of light. And here's the really wild part.
Unlike sound or smell, photons don't need air to travel. Once they're out in the vacuum of space, they can just keep on going and going forever.
So at what point does your glow stop being a glow and start being something else? Well, physicists have actually calculated this. At about 168,000 kilometers away, the light from your body has spread out so much that it's no longer a solid wave of heat. Instead, it becomes a stream of individual, separate photons.
And this is the most amazing part of all. Beyond that distance, you don't actually get any smaller. Your size never shrinks down to nothing. You simply become this lasting presence, a stream of individual photons, each one carrying a tiny signature of you, traveling out into the cosmos, for all time.
So yeah, your body is stuck here, limited by physics and gravity. But the light you give off, it has no boundary. In a very real physical sense, that makes you cosmically huge. Your physical form is finite, but your light travels forever.
Fuel your curiosity. Subscribe for the explanation. Stay for the knowledge.